Hi class, we are beginning our first geometry lesson. We're going to learn some neat things about polygons and shapes and figures, some neat things about geometry. But first we've got to lay a groundwork. We've got to, as the title of the chapter indicates, we've got to learn some essentials. We've got to get some grammar under our belt. We've got to learn some terms. We've got to learn some key ideas that we can build on for further and larger concepts. So that's where we're starting. We're going to define some things. We're going to look at some basic concepts. So notice the essential question that we want to answer. How do you name points, lines, and planes? And we're going to define those as well. You may have already looked at the vocabulary for this section. We're going to further define some things. All right, so let's get started. Again, the question: how do you name points, lines, and planes? And you can see, you know this is a point. A point is an undefined term, which we'll look at in the vocabulary. But you name a point with a capital letter. Okay, and then here we see a line, and here we see the representation of a plane, a two-dimensional figure. Okay, or two-dimensional idea. So let's look at some things. All right, we're looking first at what we call undefined terms. Sounds, how can you have a term that's undefined? It sounds a little confusing, but what we mean by that is you've got a general concept. There's a premise behind it, but there's no formal definition because the terms would require the terms we use to define would require definitions and so forth, and so you've got to have a starting point. And so these things are what we call undefined terms, and it doesn't really have to make a lot of sense to you. We won't really use that. But technically a point is an undefined term. Okay. Do you think a point has any dimension? Okay, dimension being length or width. All right, and you should have your note-taking guide out in front of you, and you should be following along and filling in the blanks as we go. But a point does not have any dimension. Okay, it doesn't have any length or width or height. And how do we represent a point? Just with a dot. On a coordinate plane, on a piece of paper, we represent a point with a dot. And how do we name a point? Again, we name it with a capital letter. All right, what is a line? How do we define a line, even though it's an undefined term? How do we define a line? A line, again, what's the dimension? It has one dimension. Okay, and it's represented by what is this? It is represented by a line. Okay, this is just the symbol of a line. Okay, so a line, theoretically, it extends out infinitely in opposite directions. So that's why you have your arrows here. Okay, so a line is represented by a line, or you might say a big dash with two arrowheads, but it extends without end. Okay, so again, what are we doing? We're getting some tools in our toolbox, so to speak. We're learning some terms and some basic concepts in order to build throughout the course of this of geometry. We need to know these things before we can learn more about triangles, about squares, other polygons, and even solids like spheres and such. All right. So now we're looking at just again terms and labeling them. Okay. So this would represent a line, and I can name a line two ways. I can name it by 2 points on a line, like this would be point A and B, so I could call it line AB, or I could put a symbol over point AB, a line symbol, which would be a dash with two arrows on it. So all three of these would read line AB. A lowercase letter can also be used to name a line. Okay, so these are all the ways that I can name this example here. All right, so I'm naming a line, but I haven't really talked about what is line. So a line, so through any 2 points, there is exactly one line. Okay, and then you can use any 2 points on a line to name it. Okay, so for example, if I had, if this point was C, okay, I can name this line AC if I wanted, or CA, or BC, that's a B, and so forth. Okay. So what is a line? How do you label it? And that's what we just were looking at. And then we have a plane. A plane has, okay, so a point has 0 dimensions. A line has 1 dimension. How many dimensions do you think a plane has? Okay, that's right. It has 2 dimensions. All right. A plane, theoretically, it extends in opposite, it extends out in 2 dimensions. It extends out infinitely. Okay, so it is represented by a shape that looks like a floor or wall, but it extends without end. So if I'm in a classroom setting, oftentimes I'll use a sheet of paper, and I'll say, okay, this sheet of paper represents a plane, and you have an infinite number of planes going through the room. Okay, and so this figure here represents a plane, this 4-sided figure, but theoretically this line extends out infinitely. This line, and this line. Okay, these are intersecting line. Well, I guess I don't know if you would say they were intersecting, because all of them intersect or extend out infinitely. Okay, and so any given square lies in some plane. Okay, and we'll talk more about planes a little bit later. And how do you name a plane? You can name it by a capital letter, like I could call this plane M or plane P, or any 3 non-collinear points. Okay, that was a term in your vocabulary. Again, building this course, I'm thinking, okay, maybe I should have a video where I go over the vocabulary. I was thinking that we'd go over it during class time, which will be the case in this point. I might change that. Okay, so through any 3 points not on the same line. Okay, so again, vocabulary, collinear. What does mean? It means with or together. Linear means line. So if points are collinear, they're with or on the same line. So non-collinear points are not on the same line. So when you're naming a plane, through any 3 points not on the same line, there's exactly 1 plane. Okay, that's the definition of a plane. So you can use 3 points that are not all on the same line to name a plane. Okay, so again, I might have a point E, F, G here. If they're non-collinear, if they're not on the same line, then I can use those points to name the plane. Okay. So let's see how well you understood this. Let's look at example 1. Give 2 other names for line LN. So here is line LN. Here's N. Here's L. So this is a line. What's another name for line LN? Okay. What do you think? All right. This one may be easy to tell. Notice the lowercase b. So we could call that line B. When you're using 2 points to name a line, the order doesn't matter. I could call this line LN, or I could also call it line NL. But also notice there's a point here, M, so I could call it line LM or line MN or line NM. Okay. Here's plane Z. Remember, you can name a plane with a capital letter. What's something else? What's another way I can name plane Z? Well, I can look for 3 non-collinear points like L, M, and P, or P, N, and M, or M, N, and P. Okay, so let's see what we have here underneath here. We've got L, M, P. Those are 3 non-collinear points. P is not on the same line as L and M. Okay, 3 non-collinear points to name a plane. We could also call it LNP or PNL. Okay, so plane. So if we were naming it, we would name it plane LMP or plane LNP. Okay, but you want to not just LMP, but you want to use the word plane as well. Okay, B. Name 3 points that are collinear, and then name 4 points that are coplanar. Co, meaning with or together, in plane or plane, so they're on or in the same plane. So let's go back to here. Name 3 points that are collinear. Can you name 3 points? Okay. LMN, NML. Okay, so L, M, and N are collinear. Did we miss any points? Okay. And then it says name 4 points that are coplanar. So we have L, M, N, and P. Okay. Is that it? Are there any other points that are coplanar? No, there are not. Okay, Q is a distractor. Q is not in the same plane as plane Z here. Notice this line here, this line A, is intersecting this plane, so it is not in the plane. Okay, it's in, whoops. Okay, it's in some other plane. Okay. Q is in some other plane. Okay, so it is not coplanar with L, M, and N. Okay. All right. Let's see how we're doing here on time. Let's look at the next example. Still, let's define some more terms. Segments and rays. Okay, so here's line AB. All right, written as AB with a line symbol over it, or spelled out line A, capital B, or even BA. And points A and B are used here to define the terms below here. Okay, so we're using line AB, and so within line AB we have a line segment. Okay, this, what we see here is a line segment. It's line segment AB, and you can write AB. You can also signify a segment with capital A, capital B with a dash over it without the arrows. Notice the difference between this one and this one. So this tells the reader we're talking about a line segment. This tells the reader we're talking about a line. Okay. So line AB, let's see, where are we here? Okay. So line segment AB consists of the endpoints A and B and all points on line AB that are between A and B. So this is A and B are the beginning and the end, so to speak, of the line segment, and then there's an infinite number, not an infinite number, but an uncountable number of points there. I don't know, maybe it would be considered infinite. And so again, notice the line, just like with a line, I could say line AB or line BA. Same thing with a line segment. The order of the named points does not matter. Okay. And then what about a ray? A ray is, now this isn't a technical term, it's not exactly right, but a ray is a half a line. It goes in one direction infinitely. Okay, so ray AB can be spelled out like this, or it can also be written as AB. Okay, with the symbol of a dash with one arrow. Now here's the thing that you have to be careful with naming rays that some students miss because they're not paying attention in this part or whatever. A ray, like where the order doesn't matter with line and line segments, the order does matter in naming a ray. Okay, you name a ray beginning with its endpoint. Okay, so this is not ray AB because A is not an endpoint. A is an endpoint. Okay, you might look at it as a beginning point, but it's called an endpoint. So A, you might look at it as ends here or starts here, and it goes through B infinitely. Okay, so this is ray AB. The other example would be named ray, let me get my pen here, ray BA, and I got to hurry up, we're running out of time. So that would be ray BA. You start with the endpoint first. Okay. Okay, so the ray AB, written as AB, consists of the endpoint A and all points on line AB that lie on the same side of A as B. Okay, so all these points that lay on the same side of A as B does, these are all consist of the ray AB. Okay, and note that ray AB and BA, like I said, are different rays. Okay, so I'm going to stop there, and we'll pick up with the lesson where we left off here.